So in this presentation, what I'll be kind of doing is kind of giving a brief introduction to AI and outlining some of the transformative roles it will play within kind of future banking services and the ways of working. So to realize the potential benefits from AI, we'll also need to address a lot of the new expressions of risk which arise from building out production AI solutions and overcoming a lot of the current restrictions in building AI products in financial services. We'll also need to really kind of key enable our staff to become more AI literate and taking AI out of the labs and really into the daily working environments. So by way of introduction, this talk, I'll just give a quick overview of these challenges and highlight some of the common kind of programs and kind of initiatives within banks that are addressing things like AI risk and building towards that kind of future AI literate workforce. So we'll start by kind of really kind of going into say, well, what is AI? So in essence, you can think of an AI system as something that perceives its environment through data, processes that data, and then takes an action to complete a goal or an objective. So this could be learning how to drive a car, which movie to recommend, or which transaction is likely fraudulent. So as a scientific discipline, it is quite broad, and it becomes more broad almost with kind of more presentations you see. So in general, it includes approaches like machine learning, of which things like deep learning and reinforcement learning are specific examples. Machine reasoning, which includes planning, scheduling, knowledge representation and reasoning, search and optimization and robotics. Here, we've got kind of a high level overview of some of the key kind of segments within that kind of broad umbrella. So analytics, kind of interactive kind of chatbot systems. You see a lot of use cases which analyze and try to interpret information from visual content. And also a lot of kind of text-based processing, particularly kind of natural language processing or NLP, some of you may have heard of. So as you're aware, in many ways, banking is being entirely transformed by the use of big data and AI and machine learning in particular. Recent surveys by the likes of McKinsey have shown that about 47% of executives across financial services ranked AI as having one of the greatest potential impacts within their organization compared to other disruptive technologies. Because of the pace of research in this area, things are moving fast, and it's really important that we stay ahead of the game. But also, things can go wrong, and as established banks, there can be very serious consequences if this happens. So I've collated just a kind of a very kind of high level macro view of some of the key future banking use cases across capital markets, deposit and lending, payments and investment management, which can really be accelerated through the use of AI. Across all of the use cases kind of mentioned here, what we can see is basically there will be a lot of significant changes in the automation, particularly around back office operations. And we'll also see kind of more specific kind of advantages taken, say, within capital markets, where we're likely to see opportunities to use analytics to match investors with capital market investments. This may be disruptive to larger players in the industries. It also reduces the defensible position by which some of the best connected firms have and really gives an opportunity to some of the least established organizations in the area to get involved. In areas such as investment management, we'll also see advanced analytics expanding access to wealth advisory services, meaning it will no longer be the preserve of the wealthy, but you'll see a kind of a leveled kind of staging of wealth advisory service for the masses. It will also become increasingly personalized. So the ability to analyze large amounts of alternative data sets will mean that we'll get increasingly more tailored advice on our services that we offer. Within all of that, it's really important to kind of contextualize what we mean by AI and really current AI or what's known as narrow. So I like to think of it like a ball rolling down a hill, trying to find the deepest pothole, but in a kind of multi-dimensional space. So this means that they're not very good at solving general problems, although they can be absolute experts at individual tasks. So some of the best performing AI algos are deep learning neural nets, which we would have mentioned. but they're also often black boxes, meaning we don't have great insight into how AI systems process the data to actionable outputs on the outside. This kind of narrowness in combination with that lack of explainability can give rise to certain weaknesses, and in particularly concern around productionization use cases are the kind of examples that we see here. So adversarial attacks, so what does that mean? So this is where there may be an attempt to trick or to perturb the data in such a way that you make the algorithm behave out of scope and actually to make an incorrect decision. Here we see a kind of a very good example, and kind of one that's shown in the kind of research of one of where we have a use case around an apple. So here someone has placed a sign over just saying iPod, and really what it's done is it's confused the classifier to an extent where it's identifying a picture of an apple with a tag iPod to as basically an iPod. And here that kind of aligns to some of the internal weaknesses of the application, where we as humans kind of quite easily recognize that actually no, it's just an apple, but an iPod. But the algorithm itself breaks down the solution to a set of discriminant features and uses that then to make the prediction. And the discriminant features being the text iPod with an image of an apple in the background. And it's using those to make decisions. So if we think of financial services use case, this could be for an anti-money laundering scenario where we've used machine learning to identify potentially fraudulent transactions. And we have malicious actors then that try and mimic or hide their transaction within normally observable patterns. And that can cause a lot of issues. The same below in terms of explainability, where we see a lot of a kind of a famous example of the kind of the wolf and husky classification. And here, the kind of what's happened is that the model, based on the training data weaknesses, has learned that actually the discriminating factor between a wolf and a husky was the presence of snow in an image. So there are a lot of kind of side effects to this, and I suppose in the next slide we see where that's actually had those kind of weaknesses have shown themselves into also pretty famous errors around AI systems. So here we've got a kind of a very high level selection of instances where AI has gone wrong. There's a famous example a few years ago where Apple were using a credit card kind of ranking system or creditworthiness system, and it was shown to basically be biased against minority class in this particular kind of gender. I suppose in essence, in summary, for applications that make it to production, or particularly for client-facing applications, we need to be very careful of the weaknesses of AI solutions and really take care of that within our development processes, and also to train our staff to be able to spot those weaknesses. Banks are often held to a higher standard than the likes of tech companies, where this might be, making a recommendation for a movie would be very different than a financial product or service. So we have to take care of those risks that could become existential in nature. So there are a lot of efforts and a lot of momentum in the financial services because of these kind of scenarios, and the regulators are taking note. Here I've got a kind of a quick overview of some of the structures that's put in place by the European Commission around trustworthy AI. There are, I suppose, defined steps which are kind of outlined, and one is really kind of having a clear understanding of what is AI and what is not AI within the organization, and what are the kind of governance controls around those applications that fall within that scope. We should also have kind of clear ethical principles and kind of guidelines around how to meet those, and really a set of guidelines to the end users to say, well, what does good look like in the context of these applications? What's really important as well is that we build out those standards and best practices and those trustworthy applications proportional to the risks of the use case. So not necessarily to stifle innovation, but use it as an accelerator where, for low risk POCs or proof of concepts, graduate the kind of governance accordingly. So how will this affect our kind of future ways of working? AI as a technology is still likely to remain narrow in the foreseeable future and really specialized to perform specific tasks. So this doesn't mean that AI isn't powerful. existing AI solutions can outperform the best human experts in many tasks across multiple domains, like medical diagnosis, playing games like chess or Go, and identifying that needle in a haystack, so that kind of suspicious transaction kind of activities. And when we combine multiple narrow AI together we can complete really complex tasks, building sophisticated applications to solve meaningful business problems. However, narrow AI means that we will need a new model or solution for each and every task we want to solve for. In fact, we may need multiple. This means we'll use AI in a task-by-task basis rather than replacing entire jobs, assuming that job isn't just single task orientated. So this will result in a lot more automation and increased augmentation. And we'll spend less time as individuals on mundane tasks and really be freed up to add more value and kind of more meaningful activities. So these gains won't be just for people working in kind of back office functions or operations who spend hours kind of prepping client meetings. Data scientists are already early winners and we can leverage a lot of kind of automated ML, kind of automated feature engineering technologies and model management capabilities, which are coming out. So we won't have or need 10,000 data scientists building complex models for each and every task possible. What we will need is pods of data scientists, engineers, product specialists, and business subject matter experts who can work together to build those trustworthy AI solutions that solve specific tasks really, really well. We'll also need to educate the end user so that they understand the limitations of AI and spot when things aren't working quite as expected. So we fail safe and we're really able to manage that risk and learn from the errors. To be successful, also organizations will need to, in essence, almost redesign those processes and jobs to be more task oriented so that AI can be used to augment certain proportion of work rather than replace. This will also mean that we'll need to enable our staff to be more AI literate, upgrading tooling and platforms, and also put in place standards and reusable building blocks that allow us to accelerate the delivery and really componentize a lot of the delivery. In this context, kind of cloud will play a really important role. So looking ahead and looking to the kind of the way the platforms are going and technology, what is certain that we'll see a lot more ML and AI solutions in production use cases. Today, we're seeing the emergence of a lot of automation and large parts of the process for getting AI out of development zones and really into production environments. Here, again, those cloud vendors are really doing for AI what Ford and Toyota did for manufacturing. With this comes its own challenges. So as more AI gets into production, we'll also need more people to monitor and control those applications. And we'll see this with, I suppose, the advancements made in AI ops or ML ops and really those utilities for model management and kind of KPI dashboards and model health. Once these become more established, what we're likely to see also is kind of that next wave of kind of focus of automation around kind of intelligent decision support systems. So helping augment humans manage the environments and manage the models in production, often which are very complex in nature. So we'll see that kind of full automation around the end-to-end kind of life cycle, and really kind of with that human oversight aspect. So hopefully I haven't gone over time too much. So yeah, open for questions.